So here we have our Pascal triangle that we defined previously. But this is a very interesting observation with the way that we got those values in our triangle. We can find these values using a pattern, using combination in statistics. So let's show that. So on the bottom, let's build Pascal's triangle by just using the idea of combination in statistics. Let's start by computing 0 combination 0. Let's go to 0, mathematics, go to the probabilities section, and now let's hit option 3. And now we got 0 combination 0, which is equivalent to 1, which is the same value that we started with. And now let's go one level lower. Now let's find the value that we obtain when we do 1 combination 0. So let's go to 1, mathematics, probability, option 3, 1 combination 0, that is equivalent to 1, which notice that is also what we got in this section. And now let's do 1 combination 1. Let's show that. It also gives us 1. And notice that this placeholder, it gives us the same location that we got when we were building Pascal's triangle. So now let's go to the next level. And now let's find the value of 2 combination 0. 2 combination 0. That is equivalent to 1. And notice that this computation gives us this value that we had in Pascal triangle. Let's move on to the next value. Now let's go 2 combination 1. Which is equivalent to 2. And notice that 2 combination 1 gives us the next value in the second row. Now let's compute 2 combination 2. That is equals to 1. In order that 2 combination 2 gives us this specific location in Pascal's triangle. And now let's go one level lower. Let's start by computing 3 combination 0. That is equals to 1. In order that 3 combination 0, it is the value that we obtain in this specific location in Pascal's triangle. Now let's increase by 1. Let's do 3 combination 1 now. That is equals to 3. And notice that that's the value that we obtained in here. It is the next value in Pascal's triangle in the third row. Now let's compute 3 combination 2. That is equals to 3. And notice that that's what we got in here, the next value in Pascal's triangle. And I hope that I can convince you that if we do 3 combination 3, that is going to give you the next value in our row. If we want to compute the next row in Pascal's triangle, we can find those values by doing the computation of 4 combination 0, 4 combination 1, 4 combination 2, 4 combination 3, and 4 combination 4. We can also use the idea of combination in statistics, and they're going to give us our values from Pascal's triangle. So now, let's define the pattern that I use to define these combination buttons. When I was defining the 0 row, notice that the left-hand side was always 0. When I was defining the first row, notice the left-hand side of the combination was of a value of 1. When I was defining the second row, notice the left-hand side of the combination, I was always using the value of 2. When I was defining the third row, notice that the left-hand side of the combination was of a value of 3. When I was defining the fourth row, notice that the left-hand side of the combination, I was always using a value of 4. So the left-hand side of the combination, it will always indicate the row number. So now let's talk about the right-hand side. What I want for you to realize is that regardless of which row I was defining, the right-hand side always started with 0. And then I was always increasing by 1. So here, there's just one number. So you start with 0. So now here I start with 0, and then I move to 1. Next row, I start with 0, 1, up to 2. Next row, 0, 1, 2, up to 3. Next row, 0, 1, 2, 3, up to 4. And this is a very important observation when we define the binomial expansion theorem. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.